Good day all and welcome to Python Coding lesson 15. In today's lesson, we're just going to complete the code for the game and we're going to run it. So if we quickly open up the game, I've already got it coded out. So if I quickly run it to show you how it looks, there's our background, the ATG background. We got our little mascot at the bottom collecting points. Whenever I use the A and the B button, I can move him left and right to collect the points. You can see the points on the top here is scoring from 0 to whatever point we have. And we have a little timer for the game. You can also see that some chips are actually falling faster than others, even yet they are different locations. We did that by just changing the movement forward. So let's go through this program and I will explain how it actually works. You can also follow on along with it. Stop that. Right, so to start off, I registered my ATG shape and my chip shape. So if I go to my folder, you'll see that in the folder, there's the ATG icon, there's the background, and there's the chip. Now you notice that if I highlight over the folder or over the file, you can actually see the dimensions, which is 56 by 60, where this dimension is 20 by 20. Remember, in Paint, you can change it. So what I did first was I pulled up from the yesterday's work that we had and I put it into one folder. So we got the window that's been created, the chips that and the ATG that's been registered as a shape. I've got the background picture, that's BG pick, background picture, and I set the background picture to background.gif, right? I've got the first pen turtle, and this pen over here is allowing me to write my score on my screen. Now you notice the pen is up and I'm hiding the turtle. That's the reason why you don't see the pen icon on screen, just like the write that we did yesterday. I then create the ATG turtle and I save the shape as ATG. I set the position, and this is where I went slightly different to what I did yesterday with y'all. The first thing I did was I set my own variables called left and right in ATG, and I set them to both false. Now what I'm doing here is I'm planning on controlling whether the icon's going left or right. So I'm not using the go-to coordinate system. I'm using the set heading coordinate system. So if I know which side I'm facing, I just have to move forward instead of worrying about what the X and Y coordinate is and moving it X spaces or Y spaces. All right. Then the next thing is I've also got a pen for time that's keeping track of the time on that corner of the screen. And you can see that the pen turtle is also hidden. And then finally, we've got our chip. Just like yesterday, I showed you how to use a list to do the chips. I got chips for I in range of 10. So it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it'll create it'll create 10 turtles in total. Remember, each time this for loop runs, it's adding it to chips. So chips is actually holding chip 1, chip 2, chip 3, chip 4, chip 5, and so on. So in order to access it, we'll need to run the for loop with a slight variation. And the slight variation is this. When I'm collecting the chips, let's go down to the movement first, so then I'll come back there, right? So what I'm saying is I'm creating a method to define if the left button is pressed. And if the left button is pressed, I'm saying, all right, then the left key must be true. So I now can move left. And if the left key is released, then I must stop moving left. So I set it to false. The same thing I did for right. And then finally, I went down to the movement. I said, all right, if the left movement is equal to true, then I need to set my heading to 180 degrees. Now remember, 180 degrees on a Cartesian plane is left, 0 degrees is right, 90 degrees is up, and 270 degrees is down. So I set it to 180 means I'm moving left, and I say move forward 5. So I'm moving forward, so I don't have to worry about changing y coordinates and so on. But what I do have to worry about is if I go past the box in the end, so if I go past this little box in the end here, what must happen? I said, if I go past this box here, it must come out from the other side. So I'm teleporting from one side to the other side of the screen. So I'm doing the same thing for the right hand side. If I go past on the right hand side, it must teleport to the other side of the screen. Next, I said, all right, if that's the case, if x coordinate is less than minus 280, go to coordinate 300. So that's when I actually use the set. So for one side, I set it to the other side quickly. The same thing I did for the right. So if right is true, then I'm going to set heading to 0, and I'm going to move 5 again. And the same thing happens for the left. It's going to happen to the right. At this time, if it goes more than 280, that means if it goes out that corner, it must come to the minus 300 corner. Right? So that's how I'm making it teleport from one position to the other. So I said, all right, let's move that, and we got the movement. So the movement's working fine. Let's start with the definition for the chip fall. So I said, all right, I'm going to define chip fall. So all the chips are falling. I said, all right, for every chip, I need to do this. So I said, for chip in chips. Now what's going to happen? Remember, chips is a list. So that list is now going to be stored in chip. So I'll have chip 1, chip 2, chip 3, chip 4, and so on. So what I'm going to do now, I'm going to take a random position for the y. I'm going to say 1 to 5. Now this is controlling the speed, how fast forward it must move. And I'm simply going to say that chip needs to move forward as long as I'm falling. And I said the same thing with the ATG. If it's too much to the left or too much to the right, it needs to start from the other side. So I said, if it goes past the border, that's that minus 300 at the bottom, it needs to choose a random position at the top of the screen and start falling again. So that's what this did. Now this chip 270 over here, it's not, I can take it out, it'll still work, because when you move it from one position to the other, it doesn't actually change heading, but I kept it there just in case, right? Now, once we've got that, the chips are falling, we need to check if the chips have been collected. So I got a definition to check if it's collected. And this time I'm going to send through points, and I'll explain points when I come to that just now. What I said was for chips in chips, if the chip's distance is less than 50. So I said chip distance and ATG. What this is doing, it's comparing the distance from the chip to ATG. So if the distance now I'm saying is less than 50, that means they are touching. We got to remember that ATG is the big icon. So that's now where it should be touching. So I said less than 50, and we saw that it was 52 or something, right? I said, all right, this part I'll come back to just now. I said, okay, we're going to choose 2 random points for X and Y, and we're going to set the position. I said at the same time, we now need to collect the points for it. So if we are collecting the points for each of those items, we now need to create a point for it. So I creating a point variable, and I set points to 0. At the same time, whenever I'm going to call up chip, I'm going to send through points, because I need to make changes to points. I need to increase it. So that's why points is in the definition. And at the end of the day, after I got my points, I need to return it so that the changes are saved for the next call, right? The next part is I've got the clear. So every time I got a point, I'm going to clear the pen that's writing my points, and I'm going to write my new points to the screen. I showed you yesterday, you can use the dot format, or you can take out the dot format and use plus and make sure that this is a string. It's only one variable that I'm changing, all right? When it comes to more than one, you can use the format. It's much more easier. Right, so that's how I'm getting my points. Then finally, after I get my points, I need to create that timer on the screen. And for the timer, it's really simple. All I'm going to do is I'm going to firstly create my game time. So I know how many seconds my game is going to be. The next thing is I'm going to have a start time. So when this game started, I'm going to take the time from my computer, and I'm going to keep it in memory. And when I got that time, I'm going to take a new time when the game is running. That means when the objects are falling, you start collecting. So for every time that this is going to constantly be repeated, and what's going to happen, I'm going to take that new time and I'm going to minus the start time. So what will happen, like let's say you started at 10:50 and now it's 10:55, so that's 5 minutes gone. So if you subtract it, it'll give you the remainder, which is 5. So I'm taking the integer part and I'm storing it in a variable called counter. And at the end of that point, I'm going to say, all right, my pen time is going to write the format, and I got game time minus counter. Remember, game time is how long, counter is how many seconds has passed when the game went through. So it'll tell 60 minus 1, 60 minus 2, 60 minus 3, 60 minus 4. It's keeping track of how many seconds. And that's how I got my counter to go through. And I said, all right, when it reaches 0, what do I need to do? When it reaches 0, I need to stop my game. So I say definition game end, and I set my position and I get my final score. And I say, right, the final score is whatever that score was. And this time I don't send through score, or I don't send through my points, because I'm not making any changes to the points. So I don't have to worry about that. I just display it. I put the game to sleep for 5 seconds, and then I say windows.by. The reason I say put the computer to sleep for 5 seconds is I don't want the game to continue, but I want to show the message. So it shows the message, then it goes to sleep. Of course, that's all the calls that I have. I'm calling up the game, I'm putting the time to sleep. This time to sleep just tells you how fast the game should run. So if I wanted the game to run slower, I can put 0.1 second, and now my game will actually run really slow there. You can see it's running very slowly. So we can actually control the speed of the game by controlling the speed timer. So if I continuously slept it or decrease the time, the game would run faster. There we go. So the more zeros you put in there, the faster the game will run, because that's the least amount of time you'd sleep in. Eventually you'll go so fast that the objects will just go past the screen and you won't be able to do much. All right. So that is the game code, and I'll run slowly through the code again to show you all the code step by step, and you can pause the video and copy it down. Of course, you can also access the code on the OneDrive that I've given you the links to. And that's the game. Now, this is just the tip of the iceberg. You can create multiple different types of games, and this is just one example. I can take the same example now and I can change it to make it look like a snake game. And all I need to do is, instead of dropping the making falling items, I can make the item move according to the key pressed. Thank you for joining me today, and have a good day before school starts.